The next part is we create a experimental data, then again we create again another notebook, that is our model training notebook, where we experiment with our models. So create one more file, that is model dot here we create a models. So like machine learning. Here we create a model training. First import requirements library. Libraries. Okay. So first of all we import all libraries and then I'll show you from sklearn dot matrices import main. So now we import all the modeling linear regression. We know that the data has a linearity and we have used or training for a regression model. So we use we don't know now which regression model is work perfectly for this data. So we import all the possible regression model here. So first is k-neighbor regressor, decision tree, random forest regression model, SVR, linear regression, lasso and regression. This is the cataboost regressor and XGBoost regressor. These are the models which is used to train the regressions model on regression output. So this is our model and we have to use the matrix to check the performance of the model. Now we have used again the model selection, which is randomize our input data, training data, so they have a more accurate on training set. After that we have to do, we import the data and label the data and we define which is x and y. So here we define the y is math score and rest of all the columns as a input variable or feature variables. So we see, so we pass here read underscore csv and we pass the data path. So my data is in the data folder as a name of the data. So first of all we go from one step back, means we go to the back folder and we have a so this all, then we saw the data da in data we choose data dot csv. So this is our data file and we df dot read pipe data. We have so that df dot df dot. prepare our x and y. X we use to drop the column of math score, and in the y for our label data is math score. So we find. So the next step is we check our x dot head, and in this we again check our data types category for our training purpose, and we convert the all the non-numeric data types into the numeric data types. So what we have to do now, we have checked the how many categories are in individual columns. So for that we choose a count or uniqueness in each column. So I write the code. So what we have to do, we create a data choose data and unique matlab numbers of uniqueness, that is count 2, and which are two, male or female. So we use the unique UNI unique function. So and print press enter, the result will be shown in the line, that is two categories in the gender, that is male and female. So we have to do the same things for all the columns, all the categorical columns. So we have to do now, we just create a loop. First of all, we create a only categorical columns data, and after that we create a loop, and then we pass the same variable in the print. So we see that the five category in the gender, so variable sub gender. So here we write the column, so column, then we read. So now this script in the line. So this is our uniqueness value. After that, what we have to do, we have to convert all the non-numerical data into the numerical data, or maybe we have only features selections. We choose the feature of only some numbers. So now we change the categorical value to numerical. So what we have to do, we have only know the category, so numerical num columns, numerical column equal to data from dot select. We have not choose the data frame because we drop the x, we drop the math score, no? So we choose only from the x numerical value. So x dot select data types, the types, where we exclude the object and dot columns. to then we run, or maybe we welcome. So now we have only choose the numerical. In this section we have to do one hot encoder and standardized scale to pre-process our data. Means we convert the categorical data into the numerical data, and the numerical data we convert into a range of standard scale. So we have used the preprocess. So we have created a variable preprocess pipeline, and where we pass all these things in column transformer. Okay. So I paused my video so I don't take that. So now I again explain this part. So we have a categorical data which is not a int or float, that is not numerical type. So first of all, create a numerical means 1010. So we choose that one hot encoder, which is a preprocessor, and we use the compose. Compose means we do a combined work. We have some same work on all columns, and which column we want to do. So we have create a pipeline. So which is a already column transformer, and in this we pass which column what I just made. So first of all, we use one hot encoder, that is the object of one hot encoder, and we change this column cat column according to one hot encoder. This is our column transform. The whole column में operation करेंगे. And then second one is standard scalar, standard object, and this is numerical columns. जितने भी numerical columns मैंने बनाए हुए columns name we can pass there. After that we fit, and procedure fit, and we again assign the x. So we see x the shape, and we see our data here. X dot head. Okay. We see that when we have some errors. So here we print our x, just because it's not showing the just showing the error because that is a data frame. First of all we choose data frame, but the x is only array type, so that is a array. So we print function use and print the all is converted into the number. So now we go to display the data, split the data, or split the data into train and test data set. Okay, so I write the code, then I will again explain. So here I will explain that we first of all import the model selection, that is a train test split, which is divide our data into two parts, that is a train part and test part. In the create a test, four variables: x train, x test, y train, y test. The x train is the input variable with the y train value, and the x test is our testing input value, and the y test is our output test value. That is our, we use x, y, and randomness, and test size is 0.2, means 20-80%. So after that we have a choose the models. So we choose model and then train the fit the model. So first of all we choose model. So I will write the code then explain. So here we create a dictionary of the models which I use to train every and each model. So first of all we create the model, then we do a loop to the model dot fit and we pass the value and we have need a one matrix. So we create a matrix functions we can use here. So we use before this we create here matrix function. So first I code then I will explain what we have to do. First of all we create the matrix evaluation. We pass the true value and the predicted value. We create the mean square error, mean absolute error, r square and root mean square error variables and return only mean square error and r square and absolute error. So after that we create a model list, a model dictionary of different regression models and then we go to the create a model list and R2 list to check the performance, store the performance of the each model. Then we start the loop for each model and then hit the model. After that we predict the value accuracy. Then we pass the y-test predicted and y-test predicted value into the matrix evaluation function and calculate the mean square error r square. Then we pass the list in the list of I, value of I, which model name and the model list append. We append the model with the list of I. Then we print different models value, just mean square, mean absolute and r square. Then we also do for the test data and that is the resultant for linear regression model. We perform the training. The mean square error is 5.3 and the mean absolute error is 4 and the r square is 0.87 and test data set for same approx 5.39, 4.2 and 0.88. So this is all model. Then we create a data frame again of model list and the r square and we create a zip file and we convert into list. After converting the list we take a name of each model list as a model name and the column name of r square list is r2 square and then we sort the value by the r square. So that is our result. So we see rigid and lasso rigid and linear regression give me the r square of 88%. That is our accuracy of the model. So we go with the linear regression or rigid. So we go for the linear regression. Then we again do same thing for better understanding. So we create the fit the model again, then linear model predict, then r square, and the accuracy is 88.1. Then we create a scatter plot of y test value and y predicted value. So the difference is showing in the scatter plot. After that we use the seaborn regression plot, create y test and y predicted of base fit line. So we created base fit line, that is our model train, and the difference between predicted and actual value is this list data frame. So this is our all model training purpose. So after that क्या कर सकते हैं हम लोग, अब इसका अलग अलग फंक्शन बना के इसको कोड करेंगे.